here. So it continues to turn anti-clockwise. Again, this is the pivot, right? Continue to turn anti-clockwise. And as long as there's contact between the carbon brush and the commutator, the current will continue to flow in the coil. Now what happens when the current now, sorry, not the current, when the coil now becomes vertical? You look at this coil here, right? It's now become vertical. Okay. Now when it becomes vertical, do note one thing. Can you see there are no contact between split ring and carbon brush? Right? There's no contact between split ring and carbon brush. And when there's no contact, that means there's no current. Right? When there's no current, that means there's no interaction between the two magnetic fields. And the two magnetic fields I'm referring to are the magnetic field by the current and the magnetic field by the magnet. Okay, there's no interaction between these two magnetic fields, and when there's no interaction between these two magnetic fields, there is no resultant force. Okay, there's no resultant force. But the coil will continue to turn because of inertia. Alright, recall back to chapter 3, the law of inertia. An object in a constant state of motion will continue to move in a constant state of motion. Now because of inertia, the coil will continue to turn. And when the coil continues to turn, the split ring now comes in contact with the carbon brush as shown here. Right, it now comes in contact with the carbon brush. And the electric current starts to flow again. You continue to turn anti-clockwise. Right? Okay, the coil will continue to turn anti-clockwise, and because right now there's a current flow, there'll be interaction between the magnetic field around the coil and the magnetic field between the magnet. Now this interaction will continue to result in an anti-clockwise motion. And the coil will continue to turn as shown here, turn again, and then continue to turn again here, and continue to turn again, until there is no more electrical contact between the split ring and the carbon brush. And at this point, no current flows, there is no more interaction between the magnetic field around the coil and the magnetic field between the magnets, and hence there's no resultant force, but the coil will continue turning. And the coil continues turning, electrical contact is made, and the current flows again, as shown in what I'm showing you here right now. Okay. So up to this point, it's pretty much very easy to recall, right? Every time when there's a current flow, you have to use your Fleming left-hand rule to determine the direction in which the coil will turn. Okay, place your Fleming left-hand rule along the coil, along one side of the coil, not the whole coil, because the direction keeps changing in the whole coil. Alright, along one side of the coil, and then determine the direction of the current flow. Now what happens is this is where it gets a little bit, you need to imagine a little bit. Alright, now let's come back to the start where the coil is horizontal, the current enters A. So at this point the current flows from A, B, C, D. And as the coil rotates anti-clockwise, continues anti-clockwise, the current enters A, right? So it's A, B, C, D. It flows along A, B, C, and D. And finally, becomes vertical, current doesn't flow. And next, as it continues to rotate, you realize at D, now at D, the current is flowing into the plane. But earlier on, at D, it's coming out of the plane. Right? Earlier on at D is coming out of the plane, now at D is going into the plane. Okay? I'm going to erase this to make it clearer. Because when the C has rotated to this position, D also rotated to this position, right? A rotated to the other position, B rotated to the other position. Right now, the position of these 4 points have really changed. This is now D, this is now C, this is now B, and this is now A. Sorry. And hence, when you look at the current flow, is from D, C, B, A. Is D, C, B, A. Okay, it becomes D, C, B, A. And it continues to turn. The current flow around the coil is still DCBA, and here is still DCBA because it's entering at D. And finally, no current flows here, and over here, now it enters at A. The current enters at A, so now become A, B, C, D. And next goes back to where we started, current flows A, B, C, D. So you realize that for every 180-degree rotation, the direction of currents change, right? So therefore, the purpose of this split ring, what it does is that for every 180-degree rotation, it keeps the current near each pole flowing in the same direction. Okay, purpose of split ring, for every 180-degree rotation, it keeps current near each pole of magnet flowing in the same direction. Take some time to digest this, right? It's worth your time. Okay, I'll see you next round.